Okay, number 6, a linear function is a polynomial function of degree 1. Polynomial degree 1. So you think about linear, the biggest exponent that you ever have on x is 1. That's why it's degree 1. A quadratic function is a polynomial function of degree 2. And that's because in quadratics the biggest exponent is a 2. Okay, every quadratic has 2 roots. So roots are similar to x-intercepts, but not quite. Describe the roots of each in words. They give us 3 graphs here. So if you were to solve a quadratic, you could get a graph that looks like this. And so if you have 2 x-intercepts, that means you have 2 real roots. So the values that make that quadratic equal 0 when you solve it, if they're 2 real numbers, like, I don't know, -1 and -3 is what the graph kind of looks like, then those are going to be your 2 x-intercepts. If you have a quadratic function that never crosses the x-axis, then you have no real roots. So your roots would be things like, I don't know, anything with I in them. 3 plus or minus 2i squared of 5 over 7. If it's got an I in it, that doesn't have a place on the graph. So imaginary roots don't show up as x-intercepts. Real roots do show up as x-intercepts. And so the only other possibility is if your graph touches the x-axis once. So in that case, you would have one unique root. So this one looks like it's at about, I don't know, -4 or so on your page. So it just means -4 solves it twice. So it's a one root, but it repeats itself. So there's only the one unique one. And let's see, how did it? But repeating root. So an example of this would be something like if you had a quadratic and it factored as an x minus 3 times an x minus 3, then it has a root at 3, but since it repeats itself twice, it's only going to touch the x-axis at +3. So that would look like the last case.